Hello, my name is Kayn Curry, and today we're going to talk about 3D printing. We are going to go over what 3D printing is. We'll talk about 3D printing outside of LIS, then inside LIS and other information institutions, followed up about things to consider when implementing this technology. What is 3D printing? 3D printing, also known as additive printing, is characterized by the addition of the z-axis. A good way to think about it is x is length, y is width, and z is height. 3D printing achieves this height by printing layer upon layer until you have a complete three-dimensional object. The most common materials used for printing are plastic filaments, bioplastic, which is a biodegradable plastic made from corn, beets, or other plants, or plastic resin. Other materials that are not as common and are often reserved for commercial or industrial use are metal, wood, cloth, and even human tissue. The most common types of 3D printing are fused deposition modeling, which uses heated filament and is comparable to a very high-tech glue gun; stereolithography, which uses plastic resin and lasers. The laser hardens the resin layer by layer. Selective laser sintering uses a fine powder in a laser. The laser passes through and hardens only the powder needed. This one is used most often with metal 3D printing. And lastly, there is laminated object manufacturing. It uses paper or plastic sheets that are cut out to specific shapes and then glued layer by layer. The ones you're most likely to encounter in LIS are fused deposition modeling, also known as FDM, and stereolithography, also known as SLA. Uses of 3D printing in the corporate and industrial realm include making plane parts, houses, shoes, prosthetics, and even human tissue. UPS and a 3D company called Fast Radius have teamed up to try and revolutionize the supply chain by the addition of 3D printers. But with all this, there's not much ecological sustainability. According to Ulrich Petschau from Ecological Economic Research in Berlin, a phone case 3D printed at home compared to a phone case mass produced in Asia has almost the same ecological impact. And as we stand now, traditional methods of manufacturing are still faster and more cost effective than 3D options. 3D printing was finally available to the everyday person starting in 2009 when the patent for FDM printing expired. This allowed for the evolution of 3D printers to be smaller, more affordable, and easier to use. Personal 3D printers can be used for figurines, toys, models, spare parts, and so much more. The only real limits are the scale of the project and your imagination. 3D printing in the library. We are going to look at the uses of 3D printing in academic, school, and public libraries. We are also going to look at other information institutions. Academic library. In a case study spanning 4 years of 3D printing at the University of Florida, it was found that a large majority of print jobs came from the engineering department. A large majority of users were students, though some faculty also used the services, and a large majority of printing jobs were for personal purposes. This study also focused on economic sustainability, but we will address that later. Uses of 3D printers in school libraries include preschool can use it for training objects and teaching aids. In elementary and secondary schools, it can be used in mathematics, history, and biology. In school libraries, 3D printers are a part of a larger conversation around maker spaces, so a lot of the research is found under that tag. In school libraries, makerspaces and by extension 3D printers enable children to develop practical real-world skills, build problem-solving abilities, and enhance knowledge transfer. Public library. Thomas Woodson argues that access to 3D printers in the public library lessens the digital divide, and providing printers is part of LIS professional responsibility. Jason Griffey states that not all libraries need a 3D printer, and often if your users need other technologies, that should take priority. Turns out my public library had a 3D printing service, so I tested it out. I found a free 3D design on Thingiverse, which is a free digital repository. Then I submitted it, and 2 days later I had some FDM 3D printed bioplastic RPG dice. Other information institutions have uses for 3D printing too. Galleries, archives, and museums can use this technology for patron outreach, especially school outreach. It allows for a hands on experience through a 3D model of things that would otherwise be stuck behind a glass or tucked away in storage for safety and preservation reasons. An accessibility use could be a raised 3D print of a work of art, allowing those who have little or no sight to still experience it. Things to consider when adopting this technology. Model lifespan. Technology that you buy today may not meet new standards or even be relevant in 5 years' time. Invest funds wisely. Consider cost, capability, and manufacturer stability. Sustainability. Financial sustainability is paramount, and breaking even is the goal. 3D print services do not operate at a profit. When considering the cost of service management, remember to include filament, repairs, waste, and labor. Patron engagement is how the usefulness of the service is determined. Patron engagement needs a strategic outreach, clear communication, and patron learning resources for hardware and software to be successful. Recommendations. Hardware recommendations are Lulzbot Taz 6, Kaiwu 3D Tycoon, Prusa MK35, and these are all FDM printers. Software recommendations are Octoprint, Astroprint, 3D Printer OS, and Slicer. If you'd like to explore this technology, here are some links to learn more. This is the end of my presentation. Here are my resources, and thank you for tuning in.